Hello everyone, welcome back to the system design series where we are discussing the concepts which are essential to crack any system design interviews. Today we will be discussing on news feed system. We will see how can we design a scalable and resilient news feed system in this session. As we all know, news feed service is the central part of any social media application. Hence, it is the preferred question of a system design interview. Facebook, Instagram, LinkedIn, all of these social media applications uses newsfeed system. As and when we open our social media account, we can see all the posts published by our friends or the entities we are following. Now, as we have acquired the basic understanding of a newsfeed service, we can understand the detailed requirement of the system only if we ask few critical questions. The phase is known as requirement gathering phase. Few important questions such as, will the feed have media information or media files such as audio, video or images along with text? How long should we preserve the feeds in the system? Is there any size limit of the post? What are the maximum number of friends we can assume for an average user? What is the scale of the system we are expecting? In other words, how many posts we are expecting per day? Should we consider notification system as a part of the news feed system? These are the very critical questions what we have to clarify before start designing the news feed system. For our use case, let's assume that the feed will have media files in it. We want to preserve the feeds indefinitely. Let's assume we have some constraint of 5 MB. That means 5 MB will be the maximum size of any post. We can assume 1000 friends of an average user. Let's assume 10 million posts we are expecting per day, and we will consider the notification system as a part of newsfeed system. With this understanding, we are ready to start designing the newsfeed system. However, to understand the scale of the system precisely, we can perform back of the envelope estimation. Let's do back of the envelope estimation before start designing the system. Remember, back of the envelope estimation is an important step to understand the scale of the system we are trying to design. Based on back of the envelope estimation, we can take few critical decisions while designing the system. In back of the envelope estimation, we will check the queries per second and the total storage requirement for our application. As we know, our system is expecting 10 million posts per day. Hence, QPS will be 10 into 10 to the power 6 by 10 to the power 5 posts per second. If you are not aware how I am converting 10 million per day to 10 to the power 7 by 10 to the power 5 posts per second, you can watch my back of the envelope estimation video so that you will get clear idea how we can perform back of the envelope estimation. That means there will be 100 posts per second. Let's understand the storage requirement for our system. During requirement gathering phase, we know the post size will be of 5 MB, and every day we are getting 10 million posts in our system, which is nothing but 5 into 10 to the power 6 into 10 to the power 7. So per day we have to store 50 terabytes of data. These QPS and the storage requirement will help us to take some critical decisions while designing the system. Idea is to start with the initial design, identify the potential issues, solving them iteratively, and eventually design a scalable newsfeed system. From the requirement gathering phase, we realized there will be 3 important subsystems of a newsfeed system: post-feed service, fan-out service, and notification service, where post-feed service will help us to post a new feed into the system. Fan-out service will be responsible to distribute the new post to all of its friends, and notification service will notify the user as soon as there is a new post available in the newsfeed system. As and when user will post something, it will be saved into the DB. We have seen that the storage requirement per day of our system is 50 TB. So obviously we need a distributed database in order to save all the posts. Fan out service will prepare the feed for all the friends of a particular user, and notification service will send some push notification to the users. Now how user will communicate with post feed, fan out service and notification service? User will communicate with DNS system to get the IP address of a particular URL. For example, the IP address of facebook.com. Once user resolves domain name with the IP address, it sends request to the load balancer. Load balancer sends the request to one among multiple API gateway. Based on the type of request, API gateway will redirect the request among post feed service or fan out service, and finally post feed service will receive a new post from the user. Fan out service will provide the list of feeds intended for that user. Fan out service sends a request to the notification service in order to send the notification to the user as and when the new feed added for a user. Let's understand the flow one more time. User will type the social media site's URL in its web browser. The URL will be resolved by domain name server and it will get the IP address. Now the browser will trigger the request to that IP address and the request will come to the load balancer. Load balancer will send that request to the API gateway. Based on the type of requests, API gateway will send it to either post feed service or to the fan out service. If it is a post request, it will go to the post feed service. If it is a GET request, it will go to the fan out service. Before going into the details in this design, let's first quickly design the APIs needed for this system. In high level, we need two different APIs. One is GET API, what user can call to get all the feeds for that particular user. Another will be POST API to publish a new post into the system. These are two high-level APIs what will be available for our newsfeed system. With this, let's start exploring the initial design and enhance the same. We will take one flow at a time and we will understand the major issues, we will solve them, and finally we will collate all the flows together to complete the design. Let's deep dive into feed publish flow, where user will consult with DNS to convert the URL and get the appropriate IP address. Then the request will go to the load balancer. Load balancer will send it to the web server. Remember, for a social media application, rate limiting and authentication are two important activity what we have to perform as and when the application gets the request. So this web server will perform authentication of the request. We can do it in various ways. We can even pass the authentication token in the request so that web server can validate it. We need rate limiting to avoid denial of service attack. It also prevents the spam and abusive content. Once the request is sanitized, it will go to the post feed service. This service will in turn store the post into a database. In this database, there can be two different tables. One will have user ID and post ID, and another can have post ID and the actual post content. From our requirement gathering phase, we realized that there could be media files like audio, video, and images. How can we store that in the database? One approach is you store the URL of the media files here in this table, and the actual content will be stored into some blob storage. In that way, our this database will be less loaded. Our fan out service also needs this information, user ID and post ID. Why? Because our fan out service will publish the same post to all of its friends feed. So obviously post feed service will also need a cache, because we realized from the back of the envelope estimation that we need to save 100 posts per second, and simultaneously our fan out service will take those posts and publish it to all of its friends feed. Hence, to make our system performant, we can have cache to store user ID and post ID. To make our system further performant, we can use CDN. What it will do, as and when user wants to post something, all the media files will be stored into the CDN system. As the CDN will be nearer to the user, it will enhance the performance by reducing the upload time. From our requirement, we know that we have to preserve the feeds or the posts indefinitely, and every day we will have 50 terabytes of content. Hence, we have to use some cold storage to store old post details. For example, after 7 days, we can move all the older posts to the cold storage. In that way, we can manage this huge amount of data efficiently. Let's now deep dive into the fan out service. In fan out service, user communicates with DNS to get the IP address of the domain and use the get API in order to see the news feed. It will go to the load balancer. Next, it will go to the web server. Web server will authenticate the request with the help of auth key. If the request is coming from some authenticated user, it will pass the request to the fan out service. The task of this fan out service is to distribute the post all of its friends. So obviously we need friend information. For that, we can use some graph database. Using this database, we get all the friend IDs of a user. It also communicate with UserDB to get user details of those friend IDs, and it consults with the cache which has been populated by the feed publish flow. In this cache, we have user ID and post ID. After that, fan out service will publish the posts into a message queue. Using message queue, we can make our system asynchronous. We can have a number of fan out workers which will pick up the posts asynchronously from the queue and prepare feeds for all of its friends and keep it in a cache. As and when user is opening the home page of the social media site, it will consult with the feed cache and fetch news feed for that particular user. Let's go through the flow one more time. User consults with DNS to convert the domain name into the IP address. It hits the get API to fetch the news feed. The request will go via load balancer. In the web server, it will be authenticated. Only the authenticated requests will go further to the fan out service. Now, fan out service fetches the latest posts from all of its friends. The friend information will be present in the graph database, which is very common to store the friend information. Fan out service will first consult with the graph database in order to fetch the friend IDs for the user. It will consult with the cache where our user ID and post ID are present, fanout service will fetch all the post IDs posted by all of its friends. It will push into the queue to make it asynchronous because we need parallel processing here. The fanout workers will take the posts from the queue and prepares the feed cache for the user. And finally, the news feed will be sent to the user and user will see it in its UI. We can also put a cache here to make our system performant. We will not go through the notification service flow because I have a dedicated video for the notification service. What is present in the same playlist, you can watch the same. Now, the question for fanout service is, should it prepare the newsfeed on the fly? In other words, should it prepare the newsfeed as and when the user is hitting the API, or it will be pre-computed? Let's discuss this point because this is very critical for a social media system. Both the approaches have some pros and cons. Let's discuss these two approaches in details. If we perform the computation on the fly and prepare the news feed for a user as and when they are hitting to our GET API, can take considerable amount of time to prepare the news feed because the entire process of fetching friend IDs, recent posts from all the friends and collating them together to display it in the user screen will take considerable amount of time. Hence, the overall user experience can be degraded. On the other hand, if they are pre-computed, it will be very fast. That means as and when user will open its home page, we can quickly populate the news feed for that user because it is pre-computed. Let's understand what is the meaning of pre-computation. In pre-computation, as and when user is publishing a post, fanout service will always look for the new post. It fetches all the friend IDs of this particular user ID and add this new post to all of its friends news feed, and it will be already prepared and kept into the cache. As and when any of its friends opens the social media site, it can quickly fetch the news feed from the cache and display it in the user screen. That is one approach which is referred here as a pre-computed approach. Now, it has a major problem. Let's assume some users who has lot of friends. Pre-computation will even be overwhelming for the system because for that user, what we consider as a celebrity will have large friend base, and preparing and keeping newsfeed for all of its friends is a time consuming task. Hence, pre-computed approach will be good for the users who has reasonable amount of friends. For inactive users who logs in very infrequently, pre-computation is an overhead for those users. Even though the system is pre-computing its news feed, user will never log in. For those inactive users, pre-computation is a waste of computation. That means we should not pre-compute the news feed for the inactive users. Otherwise, even if we pre-compute and prepare the news feed for the inactive users, users will never log in to fetch the news feed. Hence, we have to take the hybrid approach for our fanout service. For the normal users who are active in the application, we can pre-compute for them so that quickly we can show it up in their UI and the overall user experience will be enhanced. On the other hand, for users with large friend base or for inactive users, we will not pre-compute the newsfeed because for celebrities who has large friend base, pre-computation will be overwhelming for the system. For inactive users, it will be waste of computation. Hence, we can categorize the entire user base into three different categories: celebrity, normal user, and inactive user. If this user ID is of a celebrity user ID, we will not pre-compute the news feed. That means we will not prepare the news feed for all of its friends because this will be overwhelming. We will go with the news feed preparation on the fly in this case. That means any of its friend is opening its news feed during runtime, we will add the post published by a celebrity. For normal users, it is wise decision to pre-compute the news feed so that as and when they will open the application, they can see the news feed and overall user experience will be enhanced. For inactive users, as they are very infrequent in the system, it is not a wise decision to pre-compute the news feed for them. Hence, we will prepare the news feed during runtime for inactive users. Hope you have realized the strategy. Now it's time to summarize the entire session and prepare the concrete, scalable, resilient newsfeed system design. User will consult with DNS. It can either send a post request or a get request. For both the requests, it will go to the load balancer. Load balancer will pass the request to one of its web server. Web servers are responsible for authentication and rate limiting. If you are not aware about rate limiting, I have an entire video for it. You can watch, which is present in the same playlist. And then pass the authenticated and legitimate requests to either post feed service or to the fan out service. Post feed service will save all the posts coming from multiple users into a NoSQL DB where we will keep the URLs for all the media files, and media files will be saved via CDN because it will reduce the upload time if user is uploading it into the nearest CDN, and the media files will be stored into the blob storage and the URI will be stored into the post DB. In order to fetch recent posts quickly, we have thought of adding a cache which will store user ID and post ID. Fan out service consult with friends DB, which is a graph database, to fetch all the friend IDs from the graph database. We will also have user DB where we will get the user information from. To make the system asynchronous, fanout service will publish the posts into a queue. There will be multiple fanout workers who will run in parallel, fetch the information from the queue and prepare news feed for all of the users and keep it in the cache. We will categorize all the users in one among these three categories: celebrity, normal, or inactive, and based on that, fan out service will decide should it pre-compute the news feed for that user or not. Fan out service will also trigger a notification to the user via notification service. We will not go in details of the notification service because there is a dedicated video for it and it's present in the same playlist. You can watch the same. Hope you have realized how with the initial design, step by step, we have deep dive into all the flows of the system, and finally we could design a scalable newsfeed system. We also have discussed about the fan out service strategy. Should we prepare the newsfeed during runtime or should we pre-compute the newsfeed for our users? We also thought of having the older posts into the cold storage because During our back of the envelope estimation, we realized we have to store a large amount of data into our system because we want to store all the posts indefinitely. So for example, after 7 days, all the older posts will go to the cold storage and we will keep them there as a compressed format in order to reduce the overall storage requirement of our system. Hope you have enjoyed the session. If you have learned something new, do not forget to like the video. I will be adding some more system design related concepts in this channel. So do not forget to subscribe my channel. Thank you for watching this video.